my dear chemistry class 11th students and friends, assalamu alaikum and welcome to my YouTube channel Untitled Chemistry classes. Subscribe and share to take ideas and solution of this chemistry class 11th NCERT problem 1.4 from chapter 1, that is some basic concepts of chemistry for your NEET and JEE preparations. So, our problem is calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air, 1 mole of carbon is burnt in 16 grams of oxygen, 2 moles of carbon are burnt in 16 grams of oxygen. Students, remember that solution of any problem based on chemical reaction requires the idea of reaction stoichiometry and limiting reagent. This chemistry problem is also based on chemical reaction, and in this chemical reaction our reactant is carbon, and combustion of carbon or burning of carbon occurs in presence of oxygen, resulting in formation of product carbon dioxide. So, this problem, chemistry problem, is based on chemical reaction, and if I may write this chemical reaction, it is carbon plus oxygen gives carbon dioxide. Carbon dioxide is gas, oxygen is also gas, and carbon is solid. This is physical state of reactants and products. I said that a solution of any problem based on chemical reaction requires the idea of reaction stoichiometry. Number 1, reaction stoichiometry, and number 2, limiting reagent. Now, I will give you first idea of reaction stoichiometry. See, this is balanced chemical equation. Number of carbon and oxygen atoms on reactant as well as product side are equal, and in balanced chemical reaction and in balanced chemical equation, stoichiometric coefficient of carbon is 1, stoichiometric coefficient of dioxygen molecule is 1, and stoichiometric coefficient of carbon dioxide molecule is 1. Remember that in a balanced chemical equation, stoichiometric coefficients of reactants represent their moles. So, stoichiometric coefficient 1 for carbon in this balanced chemical equation represents its 1 mole. Stoichiometric coefficient 1 for dioxygen molecule in this balanced chemical equation represents its 1 mole, and stoichiometric coefficient of 1 for carbon dioxide represents its 1 mole. Remember this, that in a balanced chemical equation, stoichiometric coefficients of reactants and products represent their corresponding moles. And you know that carbon is element, and 1 mole of its mass of its 1 mole is equal to its gram atomic mass, which we call molar mass, and gram atomic mass of carbon is 12 grams. 12 grams. Oxygen is also an element but molecular, and mass of its 1 mole is also called molar mass, and its molar mass will be equal to its gram molecular mass, which is 32 grams, calculated by this method 2 into 16, because it has 2 atoms, and for 1 atom of oxygen gram atomic mass is 16. 2 into 16 equals 32 grams, which is gram molecular mass of dioxygen molecule. Similarly, mass of 1 mole of carbon dioxide is called its molar mass and is equal to its gram molecular mass, because it is compound. Compound is always molecular, and its gram molecular mass you can calculate. If you don't remember, you can calculate. Just add atomic mass of 1 carbon atom and atomic mass of 2 oxygen atoms, which will come equal to 44 grams. In addition, Avogadro principle says that 1 mole of any gas occupies volume of 22.4 liters at STP. Carbon dioxide is also gas. It will also occupy volume of 22.4 liters at STP in accordance as per Avogadro principle, or in accordance to Avogadro principle. Now look here. This is the quantitative information conveyed by this balanced chemical equation about this chemical reaction in terms of moles, in terms of mass, in terms of volumes of reactants and products. And this quantitative information, which a balanced chemical equation conveys about a chemical reaction in terms of mass, in terms of moles, and in terms of volume, is called reaction stoichiometry. So this is reaction stoichiometry, and it conveys that for 1 mole of carbon we need to take 1 mole of dioxygen molecule, and we will get 1 mole of carbon dioxide. And for in terms of mass, we can say if we take 12 grams of carbon, we need to take 32 grams of oxygen, and we will get 44 grams of carbon dioxide. And in terms of volume, because carbon is solid, for it Avogadro principle does not apply. Oxygen and carbon dioxide are gases, for them Avogadro principle applies. And in order to get 22.4 liters of carbon dioxide at STP, we need to take 22.4 liters of dioxygen gas at STP. This quantitative information is called reaction stoichiometry. Second idea, I told you that second idea, solution of problems based on chemical reaction requires second idea of limiting reagent. Limiting reagent, so let me write first, this is for this reaction, this is reaction stoichiometry. Reaction stoichiometry. Now second, limiting reagent. That reactant whose available amount amount can be in terms of moles, amount can be in terms of mass, amount can be in terms of volume, whose available amount is less than stoichiometric amount that is required as demanded by balanced chemical equation. whose available amount is less than stoichiometric amount. Limiting reagent is the reactant whose available amount, by available amount I mean the amount we take to start a reaction, amount of reaction we take actually to start a reaction. If it is actual amount is less than required amount as is demanded by reaction stoichiometry, if its available amount is less than stoichiometric amount, it acts as limiting reagent. It gets completely consumed in reaction. It gets completely consumed in reaction. I mean, whatever available amount we take it of this reactant to start a reaction, it is completely consumed. It gets completely reacted, and it decides fate of reaction. It is this limiting reagent which decides fate of reaction. By fate of reaction I mean limiting reagent decides the amount of other reactant that will be consumed and amount of product formed in that reaction. If in a reaction you identify that any one of the reactant is limiting reagent, whatever available amount you will take, it will get completely consumed, it will react completely, and it will decide the amount of how much amount of other reactant will get consumed and how much amount of product will get formed. So it decides the fate of reaction. With these two ideas, idea of reaction stoichiometry and idea of limiting reagent, I can solve this chemistry problem in no time. See, part first of this question is, if 1 mole of carbon is burnt in air, what is the amount of carbon dioxide that will be produced? And here reaction stoichiometry answers this question. If 1 mole of carbon dioxide is burnt in air, 1 mole of carbon dioxide will be produced, or 44 grams of carbon dioxide will be produced, or 22.4 liters of carbon dioxide at STP will be produced. So if I answer part first of this question, that how much carbon dioxide will be produced when 1 mole of carbon is burnt in air, its answer is 44 grams in terms of mass. You can answer it in terms of moles, in terms of volume, in terms of mass, but more often amount is answered or reported in terms of mass. Let me answer now second part of question. In second part it is said that 1 mole of carbon is burnt in 16 grams of oxygen. Identify here, available quantity of carbon is 1 mole and available quantity of oxygen is 16. Now compare with stoichiometric quantities. For 1 mole of carbon, what is requirement of oxygen in terms of mass? 32 grams, but available mass is only 16 grams. So for part second I will say that available amount, which is 16 gram of oxygen, is less than stoichiometric amount, which is 32 gram. Therefore for part second, in this reaction oxygen will act as limiting reagent. Whatever its amount we take at the start, it will get completely consumed, or it will react completely. 16 grams will get completely consumed, and 16 gram of oxygen will get completely reacted or consumed, and it will decide now how much carbon will get consumed and how much carbon dioxide will be formed. See, 1 mole of carbon dioxide requires, or I can say 32 grams of this information I take from reaction stoichiometry. I use reaction stoichiometry as a basis because this information is fixed for this particular reaction, and I will utilize this information. 32 gram of oxygen requires 1 mole, or because I have to report carbon dioxide, I will turn to carbon dioxide. 32 gram of oxygen produce 44 grams of carbon dioxide, but available amount is 16. Therefore, 16 grams will produce half what is produced by 32 grams. 32 gram produces 44 gram. 16 grams will produce its half of 44, and it is equal to 22. So, answer of part second is 22 grams. See how I did it. I used reaction information conveyed by reaction stoichiometry that for 32 grams of oxygen, 44 grams of carbon dioxide are liberated. For 1 gram of oxygen, 44 by 32 will be liberated. Therefore, for 16 gram, which is the real mass of oxygen we use to carry this reaction, 16 gram of oxygen will produce 44 divided by 32 multiplied by 16, and it will come half of 44 equal to 22 gram. So, answer of part second is 22 gram. For part first, answer was 44 gram. For part second, answer is 22 gram. Now, third part. If 2 moles of carbon are burnt in 16 grams of oxygen, identify the available quantity of reactants. For carbon, available quantity is 2 mole. For oxygen, available quantity is 16 gram. Now, compare with stoichiometric quantities. For 1 mole of carbon, 32 grams of oxygen are required. And if we take 2 moles of carbon, 64 grams of oxygen will be required, but available is only 16. Here again, available amount of oxygen is less than stoichiometric amount, required amount. Therefore, here in part third as well, oxygen is the limiting reagent. It will be completely consumed. 16 gram of oxygen will get completely consumed, and these 16 grams of oxygen will determine how much carbon dioxide will be formed. And we have already calculated in part second that 16 grams of oxygen when reacts in this reaction produce 22 grams of carbon dioxide. Answer of part third is also 22 grams. For part first, answer is 44 grams. For part second, answer is 22 grams, and part third, answer is 22 grams. And this solution is possible only when you have idea of reaction stoichiometry and limiting reagent in mind, and you just need to apply these two ideas, reaction stoichiometry and limiting reagent. You will be able to answer similar problems of this sort. Let me recall one time solution of this problem. I said that this chemistry problem is based on chemical reaction. Chemical reaction is this. I said solution of any problem based on chemical reaction requires the idea of reaction stoichiometry and limiting reagent. Reaction stoichiometry, I first said that it is a quantitative information conveyed by balanced chemical equation in terms of moles, in terms of mass, and in terms of volumes of reactants and products. And in order to get this information, remember that in balanced chemical equation, stoichiometric coefficient, first you have to write balanced chemical equation, and in that balanced chemical equation, stoichiometric coefficients of reactants and products represent their moles, and from moles you can determine mass, because mass of 1 mole is equal to molar mass, gram atomic mass of atomic element, gram molecular mass of molecular element, and gram molecular mass of compound. Second idea is limiting reagent. Limiting reagent is the reactant whose available amount or quantity in the reaction is less than required quantity or stoichiometric quantity. It gets completely consumed during the course of reaction. It determines the fate of reaction. It determines amount of other reactant consumed and amount of product formed. Using these two ideas, you can solve this chemistry problem. For part first, what I did, in part first, it is given that 1 mole of carbon is burnt. We needed to answer how much carbon dioxide will be produced, and reaction stoichiometry answers it. For 1 mole of carbon, 1 mole of carbon dioxide is produced, or 44 grams of carbon dioxide are produced, or 22.4 liters of carbon dioxide are produced at STP. Therefore, answer of part first in terms of mass is 44 gram. In part second, it is said that 1 mole of carbon is burnt in 16 grams of oxygen. But in part second, available quantity of carbon is 1 mole, but available quantity of oxygen is 16 mole. Required is 32 grams for 1 mole. Therefore, in part second, available amount of oxygen 16 gram is less than 32 gram. Therefore, oxygen is limiting reagent. It will decide how much carbon will be formed and how much carbon dioxide will be produced. How I did it, I utilized information given by reaction stoichiometry. I wrote that 32 grams will produce 44 grams of carbon dioxide. 1 gram will produce 44 by 32. Therefore, 16 grams will produce 44 by 32 multiplied by 16. It comes equal to 22 gram. For the part third, I again identified available amounts of reactants. For carbon, available amount is 2 mole. For oxygen, available amount is 16 grams. I compared these available amounts of carbon and oxygen with stoichiometric amount. You see, for 1 mole, 32 grams of oxygen are required, and for 2 moles, 64 grams of oxygen are required, but